Hello, guys and girls. Welcome to this chilly den here. It is Randy's den. I got something seemingly boring to all of us, but actually has to entail some pretty neat stuff. So just a dumb old a healthometer is what we got. It's a scale. Pretty snoozerific, right? Well, anyways, I was just talking to my buddy the other week, and I said, man, it amazes me how many things actually have electronics in them. And so a scale, you think a stupid needle and springs, and that's all you got. But this is a fancy scale. Let me tell you, actually it's a piece of crap that don't work, and either we're going to figure out why it's not working, and make it work, or I'm going to get some special parts out of it. So basically, here's what we got. It is Senior Healthometer. And there's the model number and all that. See, guys, if anyone wants to write it down. 2006. Made in China. But anyways, it is absolutely a boring, dumb scale. But the best part is when you open it up, you got something a little bit special going on here. Now, these 1, 2, 3, and 4 are what you would call strain gauges. There's 4 of them. Strain gauges or load cells, okay? And you're either going to have, on most scales, you're going to have 4 because you need 4 legs on the ground. If you only use 2, then you could lean toward the back of it and it's not going to correctly weigh you. So each one of these is a load cell, and I'll actually pop one out and show you here as we get rolling. And and it actually takes, they work actually as a resistor. They're set up, they're mounted actually into the metal, and as the metal is stressed or bent, as you bend it, the resistance goes up. And how that's measured here in our fancy, it's got a blob on the other side to measure it, and it takes all the measurements and the differences in the resistances and pops it all together and spits out an accurate weight for you. And it can do pounds or kilograms. So something pretty lame and dumb, and it's actually kind of pretty exciting here. I was actually fascinated with it, to be honest with you. I didn't even realize that it had load cells in it. I've wanted to get some load cells, in fact. Just haven't gotten around to it. Basically, like I say, you can use 1, 2, 3, and 4. Typical scales use 4, and that would be used in a full bridge, is the way they're wired up through here. In a full H bridge, typically. And if you use, you can do a half bridge too, which would use 2 of them if you're measuring, say, a skateboard. You got the 4 wheels, but each side, at the where the board mounts into the metal supports, if you had one on each side of that, you could use 2 as a half bridge and get weight correctly, or any other type of units. Even we'll say what do you call it? Just a cart, just a push cart has 2 wheels, and you hold back on it. That would use 2, but the typical uses are from 3 volt up to 8 volt on here. This one actually is 5 volt to 8 volt max. It's using 2 3 volt lithium cells, not lithium ion, just lithium cells. And how I know it's not working is because I had it hooked up, wasn't working, couldn't get it to work. Because what it did is you'd hit these 2 back ones, they're actually like buttons. You can see I'm hitting them there, mashing them. And is what they do is they actually triggered it to turn on. Well, it wasn't even turning on. I left the batteries in it. I actually forgot about them overnight. I came back and tested the batteries to see if it was drawn, and it drew one down to like 1.6 volts, and it was at 2.9. Actually, it was one of these. No, it couldn't have been. I already changed them out. But this one's at 2.9. So them are 2 new batteries. This one's 3.0, and this one is 2.9. So we're going to put them in and see if we get any readings, but I already know we're not. So I know that it's either my load cells, which I'm kind of almost doubting. I've been checking it with voltages, with the multimeter, and I just kind of got really small voltages just fluctuating around zero. So it definitely tells me there's something wrong. Probably something wrong with the CPU blob, we'll call it, which is just the IC blob. So the capacitors, there's 6 little tiny capacitors here. They all look fine and rode up and everything, so they look good. It's a matter of what's going on with more than likely the blob. I went through, and so I didn't have to hit both buttons or mess around with that. I had clamps on them, and I ended up shorting out these two right here. It's going to be hard to see, so bring you guys in. Yeah, and right there under these 2 wires, you can see I put a solder blob across that. And that shorted that out, so it should start right up without any issues, but it's still having issues. So I've tried also just jumping my lead across when I was probing it, just jumping it across here for this one to start up. It still wouldn't start, so I think that more than likely it's probably the CPU unit, which Intel is obviously going to be it's going to be junk, and I'll get 4 load cells. So let me pull this apart for you guys, and then I can show you quick. Oh, this screwdriver sucks. That's right. It doesn't stay very magnetic, so the tiny screws just go flopping all over. So, like I said, it's been a little bit chilly out. 9 degrees, so it's a little chilly down here in the den, but it's alright. Got plenty of electronics projects to keep me busy, so that keeps me happy. Got one stuffed right here. And so I can flop that around. I'm going to want to pop this out. Pop the switch. And I'm going to bring you guys in closer. Like I said, there ain't really it's a little complicated, but it's not as bad as you'd think. There you go. Here is the actual, that rubberized conductive rubber strip on the bottom actually mounts onto here. I made sure I clean that up good too. Let me zoom you in so you can see. Take a good look at it. Yeah, the rubberized strip right here is on the back side right there. See right there, that's rubberized. I cleaned that off to make sure it was getting a good connection. I used a flashlight on the front to shine into the display to make sure that I was getting, wasn't getting a real dim, lighting up real dim, and maybe it was a bad connection, but I was getting nothing. I used a flashlight, stuffed it through here just to see if it wasn't lighting up, but there were still digits popping up, but there was nothing. So like I said, I'll try getting some readings off of that, but I think it's more than likely going to be, like I said, the blob here. And it looks like we got the driver, that display driver here in this chip. I'll try to get some numbers for you there off of that. Let me see what I can do here to get you guys, so maybe you can read it also. I have to do some serious finagling. Come on, come on. Zoom it. Zoom in my hand. Take the hand away. Zoom in. Can you zoom today, please? I hope you guys can see that. Anyways, that is a tiny one there. Yeah. Let's see what we got here. Oh my gosh, I can't even see. Get enough light to see it. Yeah, I'll have to figure it out. Let me get something a little more high power. I'll be right. Back at her. Wow, I had a heck of a time getting that chip, but I did find it and figure out reading it. It is C51 24CO2WI, I or a 1. It was actually just a straight up like this, like that. So, then here's the spot on it, and it's 0630.6. It's a 8-pin. I'm guessing it's some type of amplifying chip, like maybe a dual amplifier or something like that. It's going to take all the small offsets in the resistances that it measures, and it's going to amplify them up and convert that. I believe the blob is what's actually going to do that. I tried looking up the board in that online. I couldn't find anything, but anyways, I did go and at least tune up for some reason, the darn crystal oscillator here was just sticking up, way up. But it was soldered on, so I was actually just going to hold that down, pop the screws in quick and see if that made a difference. I doubt it, though. I don't really see anything else on here. There's a bunch of tiny capacitors and resistors, but good luck. You know, I ain't going to test everything on here. And if it's more than one thing, if it's one thing, it's probably going to be more than others, which caused it, and screw that. I'll just get the load cells. The thing's kind of a wad anyway, you know. It was actually in a lot worse shape. I actually cleaned it up and put all these in the right rows and glued them down and everything, and actually made it look halfway decent for a pile of crap. So, let me slap it together quick and see if we get any action, but I don't know, dumber things have happened, so we'll see. But I ain't counting on it. What is the problem here? Move over. This thing's fighting me. Oh, that's gotta go down there. These two go in here into the switch holder. There it is. And again, with these tiny screws, you're probably going to want to go backwards. Before you go forwards, you feel them clicking, then you know you got it. The actual resistances they use, typically with a setup like this, there's actually set resistances that each one uses. Like I said, I tried to measure that, but I was getting voltage on each one, and it kept fluctuating like down to tiny, like 20 millivolts, and bouncing around to 0, and where it couldn't hardly get like a steady reading. It was all over the place. So it's very tiny readings I was getting. But there is set resistor values. It's usually 120 ohms. Then the next step up is 350 ohms to 700 ohms, and then finally you top it off with 1,000 ohms. So it all depends on the different load cells. Like I said, if it don't work here, I'll be popping them out and showing you, so you get to actually see what they look like. They're pretty cool, actually very cool. But again, all you have to do is, if you're looking for any type of information, go to Google, man. They got everything there. They are a lifesaver, I'll tell you that much. See, you're supposed to push on it. I'll try to short it out right here and see if it, here, that's why I got the fancy mirror there to see, oh, I can see it, and still nothing, not a thing. Doing nothing. Yep, so let me pull it back. I'll flip it back over. This is an on-off switch. It's a pounds or kilograms switch, so that ain't gonna matter anyway. But I still do. I got voltage coming in, so it was 3.5, and I know it seems a little bit low, and that's why I'm saying the board is drawing on it. So I'm not sure where to go next. I redid all the fittings here. It's gotta be on the back side. So let's pull it again. Now, just with the load cells themselves, now if I just pull out the load cells and the wires, these back ones, the back ones had 2 extra wires, like this one here runs to the back. And 1, 2, and 3, yeah, runs to the back. These 2 here, extra red ones, run to the back. them are actually for the switch to turn it on. So it could be off. It would be off. Laying in your bathroom, you walk in, you step on it. These two would contact, and the contacts are working. I've had them apart, and that would tell it to turn on. So it would turn on. You're supposed to actually step on it and then let off. That's what the directions were in the bottom of that. If you see all that marker writing, that's what that was for. So I knew how to use it, but it still didn't matter because it didn't work anyway. So let's see what else we got going on back here. Or is it time to trash it and give me some load cells? Yeah, but what I was saying is there's a breakout board that they make, which is basically this board. It'll take all the information out of these 4 load cells, and you can hook it up with 1 load cell to cell number 1 on the board, or up to 4. I imagine they even make more, up to 8 probably. Anywhere's in between. And that board is HX711. It's going to include the analog to digital converter, so then it can run into the blob here, and it's also going to have an op amp in there. It's going to have to boost the signal that it's getting, because it's such a minute difference that it's reading in voltages. Like I said, with the resistor, you push on it, the more you push on it, the more it stresses it or stretches it, and the more resistance goes up. And it takes that reading and brings it in to the processor, which is probably the blob, and it's going to process that information that it gets from all 4, put it together, and spit out a number to the display. So, like I said, that's HX711, and that's going to be your converter there, breakout board. So that would do that, and now I got to do some more boring stuff, as in taking measurements, just small testing things. Maybe it's just something as simple as, see, it's hard without the schematics to do this, and it ain't worth looking all day for the schematics, I know that. So let me see what I can do. Find something odd, I'll let you know. And we're back. Fun things going on here. So I did find out more. Obviously, over here, come on, is the computer. Hope you can see that. Let me turn it low. Got much room for anything around here. Got stuff everywhere. So, anyways, I did find the data sheet. Pretty much that is in I2C serial EEPROM is what that 8-pin chip is right here, and it uses 2K at 2.5 volts is what's recommended. All of these down over here, all of them on the whole list on the computer that's there, are 2K 2.5 volts. They're all just different combos of that. So now something interesting I did find is this resistor right here is a 103, and 103 is a 10K resistor. And let's see if I can bring it up so you can see it. Yeah, fall. Yeah, right there. Come on, zoom. Wad. This freaking thing don't want to zoom. It's about time for a new one. Come on. Hello. The resistor right above the 8-pin chip there. Goddamn thing. Is got voltage on one side. I'll hook it up quick. Let's see, I'll hook it to ground. I'll go to ground. I got nothing there. On this side I have 2.39. 2.39 volts. Now that thing's gonna shut off. But anyways, and I got nothing on this side. So I'm gonna try popping that resistor. If that don't work, I will be pulling out the cells. But I told you I would anyway. So let me find the screwdriver, and I'll pull this one out because I got the things off of that one. Show you what the load cell looks like. You know, a camera that doesn't want to fucking zoom for a shit. So I gotta these are a little fussy getting them apart here, so you gotta kind of wedge and work at them. There it goes. There. Here's where the button comes in and makes the contacts. You see the two, where there's two wires here, down in there, right there. And this pushes up and bounces on them, something like that. I don't know. I don't care. I'm getting pissed. But anyways, here is the load cell, and that's all it is. It's stuck on a piece of plastic here. Let me pop it off so you can get a real look at it. See the real looker. Again, that piece on the bottom there, the foot, was just for turning it, activating the on-off on it. How did I get that off before? Alright, then slide it. Come on, slide. Once you get it where you need it, you can't even slide it. You need a bigger screwdriver. Come on. Pop right out of it. There she goes. So, that is it right here. That's all a load cell is. They are absolutely neater than heck. Neater than heck. See it? Very fancy stuff. And again, it takes that stretching of the metal that it receives and brings it over here, computes it, and spits it out. So I'm not going to waste your time sitting here trying to needle this thing together and get it on camera and bore you guys to death. So I will let you go. I will let you know either way if I get it fixed or not. Hopefully it'll be quick so I can pause it and not have the camera dump my freaking video and get right back to you guys and let you know what happened. So, well, I hope you guys enjoyed. I hope maybe, oh, tip of the day. Forgot the tip of the day. The tip of the day is actually easy. It's a tip for the tip of the day. Just little needles stuffed through the caps of my, man, am I sharp, of my multimeter probes here, my DMM probes. They came with caps, and I just stuffed needles through them, and actually they work kind of decent for just needling little parts like that. I got another way that I like to use that works better, that uses the cat rating caps, the caps that just go and leave a little tip of the thing on the end. I put needles through them, actually. Here's a cap right here. I'll use the red so you can see. Yeah, fall over. Fuck you. Yeah. I'll put it on that one. And you just stuff the needle up through. That's why I don't want to fit on. But why is it all wet? Yeah, I got a needles frayed about. Where are they? I can't find them. Thought I had them. Oh, here's one. Okay. Stuff them down in here. Like that. Find the cap. Hard part's always getting it through. Not stabbing myself. But anyways, you can barely see it there. But yeah, that's how it works. You can actually grab pliers and pull it out. It's stuffed right up against the side here of the probe, so it sticks right out, and that way you can go right in and needle stuff for real tiny fixtures. So you can see it right there, the needle just sticking out of the end. Where am I here? See? Boom. That's all it is. And again, you can pull it out to add a little length to it. I like to keep them short though, so then if I'm in poking, say I'm poking on this this EEPROM here, that I don't have the big lead in there, and if I slip, then I short out two of them, you know. And I could throw sparks and ruin something. So, well, I hope you guys got to learn something, or I taught you something, or made something, some part of your life a little easier. If you like, give me a thumbs up. If you don't, give me the middle finger. And pretty soon I got a bunch more videos coming for you guys. So again, though, as always, I very much do appreciate you guys stopping by. and checking me out. Thanks, guys and gals, and have yourselves a great evening. And I went through. Here's what we're looking at. Your cells are out here. So I went through and jumped that resistor over. It still didn't make a difference. I just bodged a solder glob over it, so I'm pretty certain it's either the EEPROM or the blob blob. So this is the fun time. This is the fun time where I get to strip it all down. So I just keep the components off of it, switches and everything, and the cells, and I get to toss the plastic. So I'm pretty happy about that, I gotta be honest with you. Again, here's that rubber, see if I can get it out without killing it. The conductive rubber that sits up on the board. Oh, it ain't gonna come out. It's gonna be connected right to the LCD. Yeah, it's gonna hit to the back of that. Like I said, I wasn't even getting anything through that, but that mounts up into here. So, then I had this 3 screws, them are gone. And now it's just taking everything apart. I might be able to salvage out, well, for one, the LCD display. How about the double rack of, I got a whole bunch of singles. I don't think I have any doubles of lithium cells. The double rack there coming out of here. And again, them are tested good, so I'm going to snip them. A little hint or something I can tell you that helps me. If you ever, especially with cords, if you're ever going to clip, say this, let's see. If you're going to clip any cords or anything, it freaking kills me when people go right to the end of the cord. We'll say these guys here. We'll say, oh, it's junk. It's not reading through. There's a short or something that's wobbly. It makes me mental when people clip it, like right here, right at the very end. At least leave a little bit there, so if you ever decided that, hey, I figured out, I seen a video how to fix these. You just got to pull that out, and the whole wire will come with it. You just pull it out a little bit and resolder it and restuff it back in, and then connect your wires. Well, if you clipped it right here, you got to tear it all open then, because your wires are too short, even with plugs and everything else. And worst case scenario is, at some point, if you look back and you're like, oh man, how was that wired up? I can't remember offhand. If you got something like a plug that has 3 wires in it, if you go back and look, you can sometimes match up where the spots, like, matched up onto the plug and tell what was your ground and your live, and then your common, you know, and match them all up that way. It almost makes me shriek when people just cut stuff. Like, I'm going to save this guy here. I'm going to obviously save the load sensors. So why cut it right there? Even though chances are when I solder a new one on, yeah, not going to splice right there. Maybe just a quick wire up job, but I'll be soldering onto here. But if you also look up load cells, it tells you right where the wires go. You got your E, which will be on your board. This board didn't have it, but your E will be your excitation, which is your that'll be your difference, the range one, basically, which typically, I forget, but I believe it was the blue one on typical ones, but just even having the wires there helps you with that, you know, for back referencing, or even future referencing that you're going to do. You know, same with this board. If I ever want to play with the board, more than likely I'll end up tossing the board out, but I still have the connections here with each wire to tell you what was what, you know, and let you know. So it's just a little gamut, I guess I give you. So anyways, yeah, that's it. Save the little switch here. That's going to be a single pull double throw switch. It's got 3 attachments on the back, and I'm going to save the load cells and the mounts, and also the contacts here. Where did I put it? Right here. This contact. Because again, you still got the 2 reeds, and once they contact each other, they can send a signal. So That's actually kind of nice to have. Might as well keep the whole bottom plug right with it, because you'll need something to push in there, and it's hard to find stuff to mount upright. So, but again, that's about it. Nothing else real fancy going on here. Just tearing it down. So, I hope I made something in your guys' life a little easier. Again, and I just can't tell you how much it means to me that you at least give me a second of your time to check out my videos. I really appreciate it very much. So, you guys again have a great one. I'll let this play out. Actually, my phone will probably stop on me, so if it does, again, thank you very much. Give a thumbs up or subscribe if you feel like it, or you feel I deserved it. I would very much appreciate it. I'll save these tiny wires. They're actually very nice. I can actually perfectly put it between my teeth and strip it. It's just that perfect size. So, little wires. I got all kinds of other wires. I don't have many tiny wires, and I would call these pretty tiny. So, another load cell. God, I'm so happy I got load cells, though. I'll even keep the mounting bracket for it, because you'll know whatever I'll use it for next time, I'll definitely need to mount it. So, just remembering how it mounted up. The front ones were different, so that one was front, that one was front, that was back, two backs, and it pushed on. There's one piece missing, yeah, that. Fit right in there. Whoop! Not a fumble. That goes right, yep, in there. There it goes. Boink, boink. That's got the switch right there, and it's got the load cell. Cool. Okay, thanks again, guys.